Good afternoon, everyone. Can you hear me
Yep.
from there? Yes. I want to invite the people in the back of the room to come a little bit closer. Otherwise, you are not going to be able to read anything from the screens. You have seats here up front. So we are actually starting before time, which I think it's a first for the summit, at least in the sessions I've attended today. Let's just give it a moment so that we can have people sitting. So, hello again. Thank you for the introduction. As said, my name is José Silva. I'm R&D Director of Critical Manufacturing. And today I'm here to talk about observability. So, the capabilities that we must have in order to operate a system that runs in high or very critical environments, right? Let me start with a question, and I want to see if there is here someone brave enough to tell us. We don't need to disclose the name of the company, but how much does 1 hour of downtime cost in your company? Can you give us a number? 4,000? 4,000 euros, you say?
Ai, caramba, já estou
Pounds.
através isto a bateria.
4,000 pounds is not a lot of money, right? More, do we have other companies here? How much does it cost to have the plant stopped for 1 hour of unplanned downtime? Sorry? 1 million. Yes, that was more the number I was looking for. Thank you. I have planted someone in the audience for that. Thank you very much. Now, indeed, it can range, and we saw just now, it can range from 4,000 pounds to 1 million. We didn't disclose the currency, but USD. And of course, it can be a lot of money, right? And so, when you decide to embark on a journey towards the vision that we saw this morning, and this morning we were already talking about AI and agents and everything we will be able to do in the near future, and that is all coming together, right? But a lot of people in this room that are managing systems daily, you know that the boring stuff is still there, right? SQL Server still gives you trouble from now and then. Sometimes disks run out of disk space because everything seems flexible and elastic, but then there is an issue, or there is an hardware limitation that you find. So, running a plant, it's a complex job, and having to care about the MES should not be your primary focus. The primary focus is production. The primary focus is to put quality products in the market and succeed in the market. And so when we start this journey, you embark on a large ship towards the promised land. The land where everything produces themselves, products just flow, you have no production issues, you have no downtime, your OEE is close to 100%, and so the Industry 4.0 promise is that all these things are going to be true. But it's not today, it's only in the future, right? And so we embark on this journey, and usually it's calm waters. Sometimes in the beginning you face some issues, and you will see a few icebergs here and there, but you are able to navigate through everything you need to do in order to run your system, right? Up to the moment where you find that promised land, where the MES is up and running, the Connect IoT integration is functioning, the data platform is collecting the data, and you are showing the dashboards to the customers, right? Well, if you believe that ignorance is a bliss, I'm sorry, but this is not the presentation for you. Because behind the scenes, there are a lot of different things that can go wrong. And people managing either IT operations or even OT, they know that a lot of things can happen. And so you know that just from an MES standpoint, you have a user interface with a lot of different technologies that are embedded into that. You have equipment integration, you have the application logic, the business rules, you have data storage, you have disks that fail, you have things that run out of disk space. Then nowadays we have more and more abstraction layers, we have more and more virtualization. Sometimes you cannot find the root cause of an issue because on the machine you are seeing everything looks just great, but when you go into the actual cluster, the physical hardware is cluttered. And so you need to be concerned about virtual compute, virtual networks, physical hardware, and physical infrastructure. And all these things are needed in order to run an MES 24/7 for 365 or 66 days per year. So if you want to know all of that, we need to be able to capture that information, and more than that, we cannot spend time looking through sparse log files that are just everywhere in shared folders. We need a lot more. Logging is important, but it's not the only source of information. And so that's where observability starts. And we took a look at the past P1 incidents that affected our MES. So we went through the issues that happened with our MES, when this is the moment where the customer picks up the phone and calls into our 24/7 hotline and rings saying, well, we have an issue, it's affecting production, production is down, or it's being largely affected by this. And in this case, who picks up the phone is a product engineer. So it's not a call center somewhere in the world. It's a product engineer that will pick up the phone and will try to troubleshoot the problem together with you. So what we found out after reviewing the incident reports of these P1 incidents or fab down incidents was that around 1/3 of those incidents could have been completely avoided if proper monitoring was in place. If you could see what was happening behind the waterline in the iceberg, if you could monitor everything that was there, we could avoid about 1/3 of the events. So these are problems that would not happen if we were looking at the monitoring of our infrastructure. Then we have the other 2/3 where in one of those 2/3, instead of spending 3 to 4 hours to track down the issue, we would spend less than 1 hour because we would find the root cause way faster by looking at the observability data, by looking at system telemetry that it's more comprehensive than just logs. And of course, all of them, so the other 1/3 that is missing there, all of them, we would be able to get there faster, not a lot faster, but observability would be the place to start instead of asking people or trying to go through different folders to find the right information to troubleshoot the problem. And so having observability and investing in observability for your infrastructure and for your MES is about being prepared for the things we don't know. There are a lot of things we know that can go wrong, right? If you disconnect an Ethernet cable from a cluster from an equipment, you can bet that something will go wrong or very wrong, right? But there are other things that we don't know. Do you know from your MES or from any other system, this applies to ERP systems, PLM systems, whatever information system you are running, do you know that if you want to scale production and instead of producing 1,000 units per day, you want to produce 2,000 units per day, do you know how the system is going to react? Are you measuring every time you go into a database? Are you measuring deviations from executing the same query hundreds or thousands of times? Are you measuring the deviation of how much time does it take to run? Are there moments in the day where the system is slower than the others? Do you know this? And do you have enough proof to justify investing in more hardware or to do system tuning in more detail? These are the insights you get by having enhanced visibility. These are the things you can do in order to have proactive issue detection. If I see that I have a service, an API that is continuously degrading, even if it's by 10 milliseconds every day, I can see a trend, and I can calculate when it's going to fail, because I can see the trend, I can react before it happens. I can go either into the database or into the system or talk with the vendor in order to avoid the issue by being proactive in its resolution. And so by doing this, you can improve performance. And of course, we can respond faster to incidents. In many cases, what we want is not to respond at incidents at all, right? What we want is not to have incidents. The MES is one of the pillars to run the shop floor, but it's not the business goal to run the MES. The business goal is to run production, and that's where the focus should be. The MES needs to be there in order for production to run, and that should be the main focus. And of course, this is also important for compliance and security. Are you going into the database always looking to access logs? Do you know how many users log in on a day? If you are suffering an attack, can you see the spike in login attempts that are failed? This is the kind of information you can extract from logs. Are you doing that? These are the things, if you really care about security, these are the things you must do. And because we all know that we are going to suffer an attack. I don't know if it's tomorrow, in a week, in a month, in a year, or in 5 years. We all know that we are going to experience a cyber attack. Are we monitoring so that if that happens, and when it happens, we know fast enough in order to react? Of course, we must do everything to prevent it, but we must be able, and we must be prepared for that to happen. And so, of course, you need information in order to make decisions. And observability is all about having that information to make better decisions. And so at Critical Manufacturing, we launched earlier this year an observability service. And this service is basically composed of two different aspects. The first one is a local setup that you do within your Kubernetes cluster or within your infrastructure, where you get access to dashboards and to all the telemetry data that we are capturing. And this is not limited only for production environments. This only serves development or staging or testing environments, because you want to see the behavior of the system before it goes into production, so that you can avoid having either buggy code or slow code running in production. And so the part of the service is to provide you the tools, the dashboards, the collection of all this information that you can store locally, and you can maintain the data for as long as you want. So as long as you have disk space or you are willing to spend on data storage, you can keep the data for as long as you want. But this is not enough. Having this allows you and your IT team to set up monitoring rules. You can create alerts, you can create your own dashboards, you can do your own queries about the data. But you also need to understand the system well enough in order to do something with it. Is it normal that this API gets called so many times? Is this the expected behavior? Of course, with time, you can see patterns. You can see that the last week you had a number, today you have a different number, so you can see patterns and deltas between patterns. But we also offer, as part of this service, critical manufacturing centrally managed observability service. So basically, in this case, you can, if you want, relay production telemetry. It's not production data, it's production telemetry, meaning this is log information from the containers running in your cluster. This is information about how much disk space you still have available, this kind of information. You can relay that back to critical manufacturing, where we provide you a remote monitoring service. Meaning that we have either automated rules, and we are heavily investing also in using AI for looking into and detecting these patterns and detecting anomalies. But we also have people that look into these early indicators and will reach out to you proactively by, if they find something that can be improved. If they find a DE rule or a business rule that is getting slower, if they find an API that maybe it's not the slowest API of the system, but it gets called 100,000 times per day, and so every second or every millisecond is taking a toll on the system, they will reach out to you and say, look, this is what we are seeing. Maybe you should look into this SQL query. Maybe you should look into adding this or that index into the database. And so part of the observability offering is not only the local dashboards, but also the service itself to look into the data and provide to you monthly reports, or if we find something that is a bit more urgent, to reach out to you proactively in order to at least get your attention to the situation. How does this work? So basically, we install this observability box within your Kubernetes cluster, and this will start collecting information from the environments that are running within the cluster. Then this information either gets relayed back to us, or if you have a COE or a center of excellence, you can basically aggregate this information back to your COE, so that if you have a global oversight of multiple plants, you can look at this information yourselves from multiple perspectives. One of the great insights by using this on COE is that we are not only collecting system running information, but we are also collecting real user metrics, meaning we are collecting the number of times you click on a given button or the number of times you navigate into a specific page. This is anonymized or pseudo-anonymized, so we collect the user ID, but we don't know who the user is. Only you with access to your MES system can tell exactly who the user is. But this is very important for making roadmap decisions. Am I investing in a feature that's only used in one or two sites, or is this feature used across multiple plants? And how many times is this page being used? Maybe I have a user that complains about a specific page that is slow, but I can see that that page is accessed maybe 2 or 3 times a day. In other cases, I might have a page that gets accessed 1,000 times a day. And that maybe it's not the slowest page, but it's affecting a lot more users a lot more times. And we know in our organization, sometimes who screams the loudest gets things faster. With this, we can actually get backup data to make decisions and make informed decisions. And so I have here a bunch of slides, and I'm prepared for the fact that we may not get internet or we may not get something, but I would rather do a live demo than just show you slides with screenshots. So bear with me, this is data from testing environments that are running at critical manufacturing. So I actually don't know what's in the data, okay? But we are going to find out together. So basically, when you get access to the observability dashboards, you get access to a Grafana instance with a lot of off-the-shelf dashboards. And we are adding this as we speak, and so we are always improving either the dashboards or the data that we are collecting. I usually start with this logs dashboard. This basically gives me an overview of what's happening in all the environments that I have access to. And João already showed this dashboard or a similar one a few minutes ago. We didn't talk about it, so it was not planned, but I think it was a great segue to show that something that we did, it's actually so helpful that even to do demos of other things that are unrelated with observability, we are already using it. So, and thank you, João, for being an early adopter of the technology. And so here, you can see that we have a lot of environments. You can picture this as your COE. You have a ton of sites running, and you can collect all the telemetry from all the sites in the same place. And so when you wake up in the morning, you can just go into a page and find out if something is not functioning well. And here, let me narrow down in one or two environments. The nightly ones usually run automated tests, so usually they do have more data. Let's see. And I'm only looking for the past 15 minutes, so let me extend that. So here I can see errors or warnings or whatever is happening in the system at the time. Right? In this case, I know that I have an ERP license that's missing. So if I have an issue with my ERP, here is something this is telling me. And then I can see the endpoints that got called, and I can see what they are doing. And let's focus on one of these. And again, remember, I'm doing this completely off script because this is data from the past 30 minutes. I was already here. There is no way I could tell what's being done, right? And when I clicked there, I clicked on traces, and I can actually see a trace from a call that was made into the system. In this case, I know it called our host service, and I can see exactly what that call is doing within the system. I can see a lot of operations that take a few microseconds. I can see some with milliseconds, and sorry. And somewhere this call, this may actually not be a great example because users are cached in the system, and I was looking into a database call. But I can go back and find something else in the system. And so maybe this one can be a good example. And so when I'm on a log, I can directly jump into a trace of that API call. And in this case, I can see the API call. I can see that it took almost 70 milliseconds to execute. And I can know exactly what it did, including database calls. So in this case, I can see that there was a call to a procedure called create service history ID, and I can know exactly how much time did it take. And from experience in this case, I can tell you that it's too much time. 3 milliseconds to execute this is too much time, so I should look further in why did it take so long. Then I can see another database call here, and I can also see what was called. And so I can just drill down through all of this information, and I'm focusing on database calls, but if I had the actions, I could also see that here. I can find exactly how many times did it went into the database, how much time did it took on each attempt, and exactly what it did. So this is important first from a development standpoint. I can, while evaluating a pull request or while evaluating a new feature that is being pushed into the system, I can evaluate if the feature is being well implemented or not only from a code perspective, but from the actual behavior that's displaying from a trace perspective. But I can also troubleshoot problems when my system is slow, and is slow only in some parts of the day or only when some operations are executing. And so all of these I can track down with this feature. But of course there is a lot more information here. One of the widgets we have down below is the slowest endpoints and how much time did they take and what are the traces. I can also go into different dashboards and, for instance, see the Connect IoT dashboards and find the information from all the automation managers that are running in my plant. I can see specific database dashboards. So one of the critical aspects of our system are database jobs, some that do replication between our transactional database or online database to ODS or data warehouse. And I can see exactly how much time they are taking. And I can see, for instance, that our data warehouse job sometimes takes almost 20 minutes. And so if I have an aggregation that I know that I have a report that is being generated to ship out materials, for instance. I know that most likely I want this down from 20 minutes to 5 minutes or less. Right? And so this is giving me the information. It also gives me the average, but I can see the ranges. We also have information about the database itself, and I can tell you that, to use a concrete example, while we were, I think João and Ricardo were preparing their demo, they saw that the system was very, very slow, and they couldn't figure out why the system was slow. And so they reached out to our platform engineering team to try to understand why was that happening. And this was the dashboard that allowed them to get to the conclusion that we had an issue with our database server, and that the database server was the root cause of the slowness in the system. And so you can here see the number of transactions per second that are being executed. You can see the database response times. So we are pinging the database and measuring the latency. And if the database is overwhelmed and the CPU is reaching out to higher numbers, we are going to see this latency going up. And so this is the kind of information that's very, very useful for IT teams to look into their systems. As I mentioned, we also have dashboards for user interaction metrics. And so here I can see from all the environments we are tracking that the languages in the browser vary from English and Portuguese. And I can see the versions of the browser that are being used. Important information for us to maybe decommission a feature or use a new JavaScript function that only is available in the newest browser versions. I can also see the distribution between operating systems and between mobile and non-mobile devices. And I can also see the display resolutions that they are using and the window resolutions that they are using. We can also see the most visited pages and the time that the pages took to load. And so this is also giving me insights. I can also find different actions that the users are executing. And if I look into here, again, we are very aware not to disclose PII information, so personal identifiable information. So that's one of our concerns, and one of the things we put a lot of effort into making sure we are not collecting personal usable information, but we do collect pseudo-anonymized information. In this case, the user ID. Me, as an IT person in this case, I cannot access the MES system. I don't have credentials to log into the system, so I cannot tell who that user is. But I can tell the application owner that I found this pattern, and it was from this user, and then it's up to the application owner to go there and check if they want to. Of course, this is also helpful because you can do queries with it, and I can just go here and query the information and try to see what filters I can do with it. And as usually, live demos cannot go too well for us. Let me just check if it was my VPN connection that broke, and it was. So let's not blame the system. Let me just quickly reconnect. Sorry for that, but my internet connection closed mid-session, which is usually a good thing. And so, let me get back to my presentation and to my dashboard. Let me see if it comes back up. And there it is. So I can actually see, for this particular user, what the user did in the system. Again, I don't know who the user is, but I can tell you what it did and what was the sequence of steps that the user did within the system. And so again, this is very important information, not only from an IT standpoint, but also for product managers, program managers, or anyone that is involved with MES, designing or defining roadmap and new features. There are a ton of other dashboards and a ton of detail on each widget that we could get into. Maybe the last one I can show you is this one. This one tracks all the API requests that are made in the system, and I can know if there are unhandled exceptions that are crashing systems that they shouldn't, how many errors I'm getting. One example could be I have an automation manager that was not updated, or I have a client application that is calling MES APIs, and somehow either the token expired or something is going wrong there. I can see this from the MES perspective, that someone is making a lot of requests, and I can tell you what's the IP address that is making that request, and if the application is providing a name, we can also see that here. We can also see the current connections. This is very good to understand usage patterns. So remember, all this historical data gets stored. So if you aren't sure, let's say you are running a multi-site system or multiple sites, and you want to define the better maintenance window for a given operation, you can see how many open connections you have at a given moment in time and find patterns. Usually, at the beginning of a shift, you are going to see a spike of operators logging into the system, and then you see normal usage during the shift. But if you see something that's not what you are expecting, maybe it's someone that is infiltrated into your network and it's trying to do something that they shouldn't. And so it gives you insights to start looking for something else. And I have a special demo, I hope, for you, something that we are working on. So everything that you are seeing, this is available today. Everything that I've shown so far, it's available today. If you are a customer, please reach out to our account managers or to your account manager. They can provide you more information on that. But now what I'm going to show you is something that's not available today, but we hope to be available very, very soon. Hopefully when version 11.2 gets released, which should be by the end of September this year. And let's see if LLMs collaborate with me today. But we can also have our own AI assistant into tapping into all the telemetry data. And so we can start asking questions to our telemetry assistant. Okay? So I'm going to start with very basic stuff, like what environment can I see information from? And so basically what this is doing, and you saw both Francisco and Walker Reynolds talking about MCP. This is using MCP, or Model Context Protocol, and it's basically understanding which tools it has available, which data it can access, and basically interfacing with the LLM through this MCP client. And so basically it showed me the same environments we saw before, but then I can ask more questions. So focus on dev MES. I just arrived to the office. What are the APIs I should focus? Like P99, P95 for looking into the last 24 hours. Then again, I don't know what's there in terms of data, and I never did this exact same question, so it's always different, but we are going to find out together. Right? And so it looks into the system, and I also gave him a lesson this week. So I explained what message bus means, and it's a WebSocket, so that's why he said, well, maybe we should exclude /message bus, because he knows that the WebSocket should be an open connection that stays there for longer. And so there is some prompt engineering behind the scenes, but not that much. I was actually impressed by the results, by the way, because this can give you a lot of insights. Give me a summary so that I can share with my team. Use emojis. Make it short and focus on what we should analyze from a system perspective. Let's say the top 3. And so it already gave me the list. And now I can ask, be mindful with one thing. I'm in the lowest tier of ChatGPT. So I have a rate limit of around 30K tokens per minute. Okay, so usually when things get slower, it's basically the rate limiting of the LLM that I'm reaching. But we can actually see what the LLM is doing. And so in this case, when I ask that question, the LLM knows that the data is stored in a database. It knows the database schema. And so the LLM actually created the database query that answers the question that I made. And it not only creates one, but it creates several. And because maybe to compare, it needs to ask different questions into the database, so I can see exactly what's happening. And let me see if I have here stored one example of how amazing the technology is. So the other day, I asked the assistant to compare 2 different systems. And this is something we do often because we want to understand if from a version to another, to the next version, there are behavioral changes. In this case, we are comparing version 11.1 with 11.2 development environments. And I asked if there are, looking in the past 3 days, what are the things I should look at? What are the main differences between the behavior of these 2 systems? And then it ran a bunch of queries, and he understood that it was trying to query the database in non-existing columns, because there isn't a P95 or a P99 column in the database. So the initial query had some errors. But we are feeding the errors from the database back to the LLM, and so the LLM can get more context and learn how to do a better query. And it explained me that there was an error in the way it was building the query, and then it changed the approach and tried a different approach with an error again. It tried to use an aggregate function that doesn't exist. But it tried again, and by basically retrying different approaches, it was able to give me the answer that I wanted. And I actually went back into the system, executed the queries, looked at the queries, and understood to make sure that the LLM was not hallucinating, was not generating something just for me to look at, but the data was real. It was actually real. And we got to the information. So it can give me a summary of the difference between two environments. And, and basically told me that these two APIs, for instance, have a lot higher P95 and P99. And sorry, I didn't explain this, but we are looking at percentiles. So I'm trying to understand the 95% that fits within a specific time, or the 99% that fits in a specific duration of the API. And so it told me that there are these two APIs that perhaps I should look into. And also there are another two related, one with master data and another with get data for perform setup, that increased in latency in 11.2 compared to 11.1. And in this case, I know that we are doing enhancements to these features. So my immediate action is to take this information back to the team and say, look, this is what I'm seeing from an observability standpoint. Please review the implementation and make sure we have benchmark tests and performance tests for these two APIs. And so this is something that if I was looking into the database, either I knew, or it would take me some time, either to build my own dashboards or to build my own queries. And in a few minutes, or even less than that, we could get this information. Now imagine what you can do with the information of all your sites together in the same database. The questions you can make, the time you are spending today building dashboards and making reports, that you can spend elsewhere doing something to help production. And so I think we are 5 minutes before the end of the session. This is all from me. If you have any questions, I'm available. Thank you very much.